So today we will take a few more properties of the trigonometric functions and see these properties are not in the syllabus, but from other examination point of view they are important. So I will be taking them few of them uh, so that it facilitates you in your this working of more typical problems. So here that day we proved that tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy under the condition that xy is less than 1. Today we would be taking up another condition that if xy is greater than 1, then what happens? Or if xy is exactly equal to 1, then what happens? So these are the conditions which we will say, and there will be two cases. Even if xy is greater than 1, then we will see that xy is greater than 1, then if x is positive and if x is negative. So effectively you will be getting two cases therein also. So today we prove the property that tan inverse x plus tan inverse y is equal to what? So we will show that this is equal to tan inverse, of course, see x plus y upon 1 minus xy plus pi, yes, plus pi, when if this is important, if xy is greater than 1 and x is greater than 0. Now here see, if x is greater than 0, xy is greater than 1, then obviously y will also be greater than 0. So whether you write or you don't write, it exactly means that if x is greater than 1, then y will also be greater than 0. So that is understood. And second case would be that it is not, just hold on. Now it's okay. And the second case would be that it is equal to tan inverse x plus y upon 1 minus xy minus pi, provided if xy is greater than 1 and x is less than 0. And again here see, if x is less than 0, xy is greater than 1, it obviously means that y will be less than 0. And this will be equal to pi by 2 if xy is equal to 1 and x is greater than 0, and this will be equal to minus pi by 2 if xy is equal to 1 and x is less than 0. So these would be the properties which we shall be taking up today. So let's give the proof of the first one, and then we will prove the other parts. So as usual, we will in proving these results, the basic this methodology adopted will be employed will be that we have to keep in our principal branches. For tan inverse, we know it is from minus infinity to plus infinity. So here these x and y, they can be any numbers. But only the condition given is xy greater than 1. Earlier we have seen that if xy is less than 1, then it is only x plus y upon 1 minus xy. So now see, so what you will assume, let tan inverse x is equal to say theta 1 and tan inverse y is equal to theta 2. Fine. So this implies basically x is equal to tangent theta 1 and y is equal to tangent theta 2. Now let us work it out here. where this theta 1 and theta 1 and theta 2, where they do belong to. Now, here see x is greater than 0. Then obviously see, you know that they will be belonging where to? In the interval 0 to pi by 2. The principal branch of tangent theta is what? Minus pi by 2 to plus pi by 2. From minus pi by 2 to 0, the values are negative, and from 0 to pi by 2, the values are positive. So here x is positive, y is positive. So obviously tangent theta 1 is positive, tangent theta 2 is positive. So both theta 1 and theta 2, 0 will be greater than theta 1, will be greater than pi by 2, and likewise theta 2 will also be equal to 0 pi by 2. This is one result. Okay. Now come to, if xy is greater than 1, what does it imply? This implies that tangent theta 1 into tangent theta 2 is greater than 1. Please see, this is the additional condition which has been given to you. Okay. Now see, what does this imply? This implies that tangent theta 1 is greater than tangent 1 upon tangent theta 2, that is cot theta 2. Mind it, what we are doing? We are dividing both sides with 1 upon tangent theta 2, and tangent theta 2 being positive, therefore it will not affect our inequality. So if we are dividing both sides, what we will get? Here tangent theta 2 will cancel, here we will get 1 upon tangent theta, and at place of that we are writing cot theta 2. Here see, it is important that you will write tangent theta 2 is positive. Then only see, when you are dividing an inequality by positive number, then see the sign of inequality remains unaffected. Otherwise see, it reverses. If you are multiplying with negative quantity, then what will happen? Then see, the sign will reverse. Now see, here you take greater than 0 because you are taking tangent theta 2 to be a positive number. Now, with this understanding. Now, what it is tangent theta 1 is greater than, and cot theta 2 you can well again write to be what? Tangent pi by 2 minus theta 2. Okay. Because this will be cot theta 2 only, and since it will be lying in the first quadrant, therefore it will be having a positive sign. Now, you know that the graph of tangent theta, that's an increasing graph. Therefore, what you can write is theta 1 is greater than pi by 2 minus theta 2, and here please do write that graph of tan theta is increasing throughout in its principal branch. Therefore, you can safely assume, and this will fetch you important result that theta 1 plus theta 2 is greater than pi by 2. This is result 1. Okay. So if theta 1 plus theta 2 is greater than pi by 2, fine. So what you are getting is, now, and then see, this has been pi by 2, this has been pi by 2. So from 1, see, we can easily derive an important result that 0 will be greater than, if we add up theta 1 plus theta 2, so it will be less than what? Pi by 2 plus pi by 2, that is pi. So this is say result 1a. This is 1a. Now see, if we combine this 1a and this result 2, this is result 2, then what we will get? Then see, we will get, see this I will write separately somewhere so that you can easily see it. So together they will give me an important result. Okay, let me write over here. That 0 is less, this thing, theta 1 plus theta 2, here it is greater than pi. Okay, so pi by 2 is less than theta 1 plus theta 2, and this is less than pi. This is what you got. Obviously, this pi by 2 to pi interval is not in the principal branch. So theta 1 plus theta 2 somehow has to be brought into the principal branch. So what we can do? Subtract pi throughout. So subtracting pi throughout will fetch you what? Pi pi by 2 minus pi is less than theta 1 plus theta 2 minus pi, and this will be pi minus pi. So what you will get? Minus pi by 2 is less than theta 1 plus theta 2 minus pi, and this is less than 0. This is our result 3. This is our result 3. And this is the main result which we are looking for. Because now we have been able to bring this theta 1 plus theta 2 minus pi within our principal branch. The principal branch of tangent theta is where? It is between minus pi by 2 to plus pi by 2. So we are now safely here. So let's now do our exercise. Now please see, what is this value equal to? Tangent theta 1 plus theta 2 minus pi. This can be well written to be what? Tan, you take minus sign common, and pi minus theta 1 plus theta 2. And this is what? This is nothing. Tan pi minus is minus, and tan pi first you write tan pi minus theta 1 plus theta 2. Okay, this is both thing. Now pi minus this thing. Since it is pi, so it will be minus, and tan will remain tan, tangent theta 1 plus theta 2 plus theta 2, and this it will be falling in the second quadrant. In the second quadrant, this tan fraction is negative, so you will be getting one more negative sign apart from this, minus minus, and eventually you will get only tangent theta 1 plus theta 2. So this is the most important result. What you got is that tangent theta 1 plus theta 2 minus pi is equal to tangent theta 1 plus theta 2. And tangent theta plus 1, tangent theta 2 will give you what? It will give you what? Tangent theta 1 plus tangent theta 2 upon 1 minus tangent theta 1 tangent theta 2, and this is nothing but x plus y upon 1 minus xy. So now here, this result, you take tan inverse, so what you will get? So theta 1 plus theta 2 minus pi will become what? Taking tan inverse, it will fetch you what? Tan inverse x plus y upon 1 minus xy. Okay, so here, see, this is from here. Now, bring this pi this side, you get the result, and place, put the values of theta 1 and theta 2. Theta 1 is what? Tan inverse x plus tan inverse y is equal to what? This pi you bring other side, pi plus tan inverse x plus y upon 1 minus xy. And this is the result which you were looking for. This was the result which we were looking for. So we have proved it. Now we will prove another result. So this result has been proved. Now see what we can do. Let us prove the other part here. Okay. Second property. What that second property has to say, let us see. Okay, let me. Now, second property, see, can be derived from this property also. Because see, just now what you have proved. You have just now proved that tan inverse x plus tan inverse y is equal to pi plus tan inverse x plus y upon 1 minus xy. Okay. Where what was given to you? Xy is greater than 1 and x is greater than 0, and y is also greater than 0, and further that's all. These three things were given to you. Okay. Now see, we will prove another property, and what we will prove that now see tan inverse x plus tan inverse y is equal to, yes, it will be minus pi. This time it will be minus pi plus tan inverse x plus y upon 1 minus xy, where xy of course will be greater than 1, but both x and y will be less than 0. This time we have to prove this result. Okay, let this be number 1 and this be 2. Now there are two ways ways for obtaining this result. One is that you proceed independently, the way we did in the first case, and derive the result. But then there is an indirect method, which of course will cut short this entire calculation work, and that is that we will try to achieve this result from 1. Because see, because into what is happening, into x is greater than, less than 0 and y is less than 0, this implies minus x is greater than 0 and minus y is greater than 0. And of course, xy is greater than 1 here, and then minus x into minus y will also be greater than 1, because minus xy is nothing but xy. So see what actually is happening with this. If you take minus x and minus y, then see this will correspond to the result 1. So in result 1, what we do, if x and y, so what we do in result 1, if x and y we replace by minus x and minus y, because here this result is when x is greater than 0. So here see, if minus x is greater than 0, please see, and minus y is greater than 0, so in equation 1, let x and y be replaced respectively by minus x and minus y. Because this formula will hold good for the obvious reason that here see only what you need, xy should be greater than 1, minus x is greater than 0, y is greater than 0. So now see, at place of x and y, what we need to do? We need to replace them by minus x and minus y. Because if we are replacing x and y with minus x and minus y, then all the three conditions are getting satisfied by this. Minus x greater than 0, minus y greater than 0, and minus x into minus y is greater than 1. So putting minus x and minus y in 1 in place of x and y respectively, what we get? Let us see. We will get tan inverse minus x plus tan inverse minus y is equal to pi plus tan inverse, yes, minus x plus minus y upon 1 minus x minus y. So this is nothing but minus. Now we know tan inverse minus x is what? Minus tan inverse x. Likewise here it is what? Minus tan inverse y is equal to pi plus minus, let me take common from the numerator. So what I will get? So I will take a minus sign. So minus tan inverse, I will get x plus y, and this xy, so 1 minus xy. So now see, multiplying by throughout this minus sign, what I will get? Tan inverse x plus tan inverse y is equal to minus pi plus tan inverse x plus y upon 1 minus xy. So this is the result that when x is less than 0, y is less than 0, and xy is greater than 1. Then this would be the result. This would be the result. So see, as I said earlier, that there will be an indirect method for obtaining the result. This result could well have been derived independently the way we derived the first result. Okay, that is, we would be going away from the principal branches, and then see, we will change the thing and we will come back here in the principal branch, and then see the result will follow. So my request to you is that you follow it, you do it independently as well. Now see, we will, so this is, oh yes, okay, pi by 2 case is also left out, so let me cover that also. Okay, so same thing, for the same result, tan inverse x we have assumed theta 1, and tan inverse y equal to theta 2, that we have assumed, let, and see what this time is this time what you have to show, that if xy is equal to 1 and x is greater than 0. X is greater than 0 obviously means y is also greater than 0, because if x is greater than 0, xy is exactly 1, then y ought to be greater than 0, because if it is negative then you won't get that result. Xy can't be equal to 1, it will become a negative number, one positive, one negative. So herein we will show that tan inverse x plus tan inverse y is nothing but simply pi by 2. How to prove this result? Okay, let us see. Xy is equal to 1. Xy is equal to 1. What does it imply? This implies tangent theta 1 into tangent theta 2 is equal to 1. So tangent theta 1 is equal to how much? 1 upon tangent theta 2, because tangent theta, this is equal to 1 upon tangent theta 2. Okay. So this is cot theta 2. Cot theta 2 I will write again tangent pi by 2 minus theta 2. Okay. So what does this imply is that theta 1 plus is equal to pi by 2 minus theta 2, or theta 1 plus theta 2 is equal to pi by 2. So this is how our analysis gives us that the sum of theta 1 plus theta 2 is nothing but pi by 2. Once you get pi by 2, then what the thing is? See, very simple here, that tangent theta 1 plus theta 2 will be how much? It should be equal to tangent pi. This is tangent pi by 2. Theta 1 plus theta 2 will be equal to tangent pi by 2. And what is this tangent pi by 2? It is yes, theta 1 tangent theta 1 plus tangent theta 2. What it is? It is tan pi by, no, it is not, we will not write this way. Wait, tangent theta 1, you just open it up. It will be tangent theta 1 plus tangent theta 2. Okay. So what you are getting effectively, theta 1 plus theta 2 is equal to this thing. Okay. Upon 1 minus tangent theta 1 tangent theta 2. Okay, so it is, you are basically x plus y upon 1 minus xy. Now here see, xy becomes 1, it gets undefined. So from there itself, see, you can find it out that this theta 1 plus theta 2 ought to be pi by 2. Because see, xy is equal to 1. Here itself, this will also imply that this thing is fetching you what? Theta 1 plus theta 2, you have proved pi by 2. So now at place of this thing, you can put the values. Theta 1 is what? Tan inverse x plus tan inverse y is equal to pi by 2. This is the result. Likewise, you can prove the other result, that this tan inverse tan inverse x plus tan inverse y will be equal to minus pi by 2, provided this thing x is less than 0 and xy is of course equal to 1. Xy is equal to 1. So now see here, see we shouldn't open like this. We shouldn't open like this. From here itself we will get the result. No need of writing this thing. As soon as you get theta 1 plus theta 2 is equal to pi by 2, it is simply indicative of the fact that tan inverse x plus tan inverse y is equal to pi by 2, because you are putting the value of theta 1 and theta 2 from here. Okay, now see, same analysis. This time what you are doing? Yes, what we are doing is that x is, again see, if case, now, okay, right, I will write over here, please see to it. Case now is, if x is less than 0, y is less than 0 and xy is equal to 1, then tangent, we have to prove tangent theta 1 plus theta 2 is nothing but minus pi by 2. Simple. This result again can be obtained from the first result in the indirect manner. Because how? Now see, we know. So what you need to do is that instead of deriving it independently, just now as we have did, because right now what we have proved that tangent theta 1 plus theta if let, okay, tan inverse x is equal to suppose theta 1 and tan inverse y is equal to theta 2, then what we have shown that tangent theta 1 plus theta 2 is equal to pi by 2 if what? X is greater than 0, y is greater than 0 and xy is equal to 1. And now we have to prove this result that here only that tangent theta 1 plus theta 2 is equal to minus pi by 2 if x is less than 0, y is less than 0 and xy is equal to 1. This result we have to prove it. Alright. What we want to show? Okay, I will write here. To prove what we have to prove here, please see. To prove that if tan inverse x is equal to theta 1 and tan inverse y is equal to theta 2 and then tangent theta 1 plus theta 2 is equal to minus pi by 2 if x is less than 0 and xy is equal to 1. X is less than 0, xy is equal to 1. These together will imply y is also less than 0. Y is also less than 0. No, hardly must be. So this result we can easily obtain from here because see here what the thing is. Let me call this result to be 1. Let me call this result to be 1. So what here? So now see now what is given? X is less than 0, y is less than 0 and xy is equal to 1. Now see what I do. I will, so minus x will be greater than 0, minus y will be greater than 0 and minus x into minus y will be equal to 1. Because minus x into minus y is nothing but only xy. So now these values, let me substitute in 1. Substituting these values in 1. Substituting these values in 1, what we get? We get, please see, we get what? Yes, tangent, what we have shown, tangent theta 1, yes, please see, tan inverse x. At place of x, what I will write? Minus x plus tan inverse y. No, you didn't write tangent theta, you wrote tan inverse x. Please correct it, tan inverse x plus tan inverse y is equal to pi by 2. So tan inverse minus y is equal to pi by 2, where of course where these conditions are given, where minus x is greater than 0, minus y is greater than 0 and minus x minus y is equal to 1. So here see what you get. Using the property tan inverse minus x is minus tan inverse x, what you get? Minus tan inverse x plus minus tan inverse y is equal to pi by 2. Multiplying this thing with minus sign, this equation throughout, what we will get? Tan inverse x plus tan inverse y is equal to minus pi by 2. And this is the result which we were looking for. When minus x is greater than 0, minus y is greater than 0 and minus x minus y is greater than 0. Or this thing, at place of minus x greater than 0, what you can write? X is less than 0, y is less than 0 and xy is equal to 1. So this result can be proved from the result 3. So these are all the results which we have proved regarding the tan. Now we will quickly come to see that what are the results which we can obtain for sin inverse x plus sin inverse y. Sin inverse x plus sin inverse y. Okay, you will see to that also. So yes. Now there will be certain conditions imposed over them. So those conditions we will check in before taking it. So first result here would be that sin inverse x plus sin inverse y is equal to sin inverse Yes, x under root 1 minus y square plus y under root 1 minus x square within brackets. Under what condition? Two conditions. If xy is less than 0, one thing, xy is less than 0, or if xy is greater than 1 and xy is greater than 1 and no, xy is positive, xy is greater than 0 and x square plus y square is less than 1. So in both the situations, see, we will try it. Let me check it. X is greater than 0, y, yes. Okay, it's okay. Now see, very simple to prove it. So two conditions, either xy is less than 0 or xy is, if it is greater than 0 and x square plus y square is less than 1, then see sin square this thing, sin inverse x plus sin inverse y is like this thing. So how to prove it? Proof, please see. Very simple. Same thing. Let sin inverse x is equal to theta 1 and sin inverse y is equal to theta 2. Where, so obviously this implies x will be equal to sin theta 1 and y will be equal to sin theta 2. Let us see where this theta 1 and theta 2 will lie. Now see that now one thing is obvious, that here see x and y, their modulus value will be obviously less than 1. Their modulus value ought to be less than 1. Then only see sin inverse x and sin inverse y will be within their principal branches. So that is to be understood. That for x, see, mod x should be less than 1, and this for y, mod y is also less than 1. Okay. Now one thing is pretty obvious. If xy is less than 0, if xy is less than 0, then what it means? It means one is positive, other is negative. One is positive and other is negative. So here see, suppose x is positive, y is negative. So theta 1 will lie there. Because if you look in the graph of sin theta, then see, from minus pi by 2 to 0 they are positive, and from 0 to pi by 2, so let here. Now, if xy is less than 0, let x be greater than 0 and y be less than 0. Suppose y be less than 0. Because only two conditions will happen. Either x is greater than 0, y is greater than 0, or x is less than 0, or y is greater than 0. One of them will be positive, other will be negative. Because if both of them are negative, both of them are positive, then they will be positive. So that's okay. So if x is greater than 0, then what does it mean? Sin where this theta 1 will lie? See, if you look at sin inverse x, then theta 1 will lie wherein? It will lie between 0 to pi by 2. Okay. So please see to it. It's simple. 0, this is pi by 2, and this is minus pi by 2. So theta 1 is this side, theta 2 this side. So theta 1 plus theta 2 will be lying where? In the principal branch only. In the principal branch only. Because that we have already seen. Because if it is theta 1, suppose here or here, so do depending which is farther from 0, that side the net result theta 1 plus theta 2 will come out. If theta 1 is its numerically absolute value is greater than theta 2, then the theta 1 plus theta 2 will be plus, will be between 0 and pi by 2. And if it is negative, if theta 2 absolute value is greater than the absolute value of theta 1, then of course the net result of theta 1 plus theta 2 will lie between minus pi by 2 and 0, because that will be negative. But anyway, it's simple to see like this. So there are no issues. Once theta 1 plus theta 2 are within their principal branches, then of course no issue, because then sine theta 1 plus sine theta 2 is nothing. That is sine theta 1 cos theta 2 plus cos theta 2 cos theta 1 sine theta 2. Putting their respective values, what you will get? Sine theta 1 is what? Theta x. This is x. And cos theta 2 is y, so it will be sine y. Theta 2 is y, so you know it is 1 minus sine square theta 2. So 1 minus y square, you put the values and you will get this. This is 1 minus x square. Okay. And then see, you take the inverse. So theta 1 plus theta 2 will become what? Sine inverse x under root 1 minus y square plus y 1 minus x square. And at place of theta 1 plus theta 2, what you will write? Sine inverse x plus sine inverse y is equal to sine inverse this whole thing, x under root 1 minus y square plus y 1 minus x square, and this is your result 1. When xy is less than 0. So simple. Once you are within your principal branch, then no issues. Theta 1 like this thing. So I have written in this manner. Otherwise, what you will do? If x is greater than 0, you could have shown it rigorously. How? That x is greater than 0. It means x is greater than 0 means sine theta 1 is greater than 0. So it means that this theta 1 will lie wherein? That theta 1 will lie between 0 and pi by 2. 0 and pi by 2. And theta 2 will lie where? Minus pi by 2 to theta 2 will lie between 0 and minus pi by 2. So you add these inequalities and see, you are justified in adding. Left you add, right you add. So what you will get here? Minus pi by 2 is less than equal to theta 1 plus theta 2 is less than pi by 2 equal to. So more if rigorously you can show it like this also, and then you can proceed. But this is a good method, a geometrical method of proving, showing that theta 1 plus theta 2 will be this way. Because see how you add on the number line, theta 1, then theta 2. If theta 2 would have been positive, you would have gone right side. If theta 2 is negative, you would be going this line. Now if absolute value of theta 2 is smaller than the absolute value of theta 1, then you will be on the right side of 0. If it is absolute value of theta 2 is greater than that of theta 1, then of course you will be venturing in this 0 minus pi by 2 to 0 interval, and as such it will be negative. So both ways. Now I think you will have acquired good amount of perfection. So first result you have been able to deliver if xy is less than 0. Now let us see the second part. Second part. Again see in the second part what you have to show. That this time see, so first part you have shown, now this part. Xy is greater than 0 and this thing x square plus y square is less than 1. And one more thing is given here. Here see x is greater than 0. X is greater than 0 has been given. And yes, xy is greater than 0 and x is also greater than 0. Then only see, x is greater than 0 means y is also greater than 0. Then see, you have to prove this result. Let us see how we can prove it. Now see, xy is greater than x is greater than 0 by xy is greater than 0. Xy is greater than, not 0, it is greater than, hold on, yes, it's okay. Xy is greater than 0 and x is square. Okay. X square plus y square. Okay. Xy is greater than 0. Fine. Now it is for both the cases. Please see, it is for both the cases. Xy is greater than 0 in this thing. Now, if x is greater than 0, then y will also be greater than 0. Please see. X is greater than 0, then y will also be greater than 0. Likewise, if x is here negative, then y will also be negative. So, either both of them will be positive or both of them will be negative. But anyway, we will see how this result can be obtained. So, let us take the first case. Case first. What is this? X is greater than 0, y is greater than 0, xy is greater than 0, and x square plus y square is less than 1. Now, x square plus y square is less than 1 implies what? This result. From here, see, what you can deduce is that sine square theta 1 plus sine square theta 2 is less than 1. Or sine square theta 1 is less than 1 minus sine square theta 2. 1 minus sine square theta 2, which is equal to nothing but cos square theta 2. So sine square theta 1 is less than cos square theta 2. Cos square theta 2. And this cos square theta 2, I can well write to be what? Sine square pi by 2 minus theta 2. So effectively what you get is that sine square theta 1 is less than sine square pi by 2 minus theta 2. Now, once you get this result, and then see your knowledge that sine graph is throughout increasing function, just like tan function. So, you can safely write theta 1 is less than pi by 2 minus theta 2, and here you do write that sine theta is increasing function, in its principal branch, principal branch. This is important. Then only. Now this result means what? Theta 1 plus theta 2 is less than pi by 2. Now as soon as, so theta 1 plus theta 2 is less than pi by 2. Of course, see, x is greater than 0, y is greater than 0. What does it mean? That 0 is less than theta 1 is less than pi by 2 and theta 2 is less than 0 is less than pi by 2. So theta 1 plus theta 2 you can show is less than what? Is greater than 0. That's all. This thing will be pi. So that we will leave it right now. What we have shown, it is pi by 2. Left inequality we will take. So point is that theta 1 plus theta 2 is lying between 0 and pi by 2. 0 and pi by 2, that is, it is in its principal branch. It is in its principal branch. Once the theta 1 plus theta 2 is in its principal branch, then see, there is hardly anything left out to be shown. Because then what you will write? You will write say sine theta 1 plus sine theta 2 and you will expand it. It will be sine theta 1 cos theta 2 plus cos theta 1 sine theta 1. And putting the values, what you get? X under root 1 minus y square plus y under root 1 minus x square. And then see, you take the inverse. So when here you take the inverse, what you get? Theta 1 plus theta 2 is equal to sine inverse this whole thing x under root 1 minus y square plus y and 1 minus x square. That's all. And then put the value of theta 1 plus theta 2, you get the result, because theta 1 plus theta 2 is nothing but it is sine inverse x plus sine inverse y is equal to same thing. You got the result under this condition. Now please see, the same result you could have, now the other case would be what? If x is negative, y is negative. If x is negative, y is negative and x square plus y square is less than 1. So hardly anything to be done there. Here see, same analysis. In the first result, what you need to do is, if x, you put minus x and minus y. And then see, you will get this result. Because if you put x and y here, for obtain now case 3, that is x is less than 0, y is less than 0 and x square plus y square is less than 1, then again you have to show that sine inverse x, then sine inverse x plus sine inverse y is again what? Same thing, same result you get. Sine inverse x under root 1 minus y square plus y under root 1 minus x square. And this result indirectly can be proved from this result, first result. Because see what you need to do. Here see if x is less than 0, this implies what? Minus x is greater than 0, minus y is greater than 0. And this thing will be same, minus x whole square plus minus y whole square will be less than 1. Now see, what you need to do is, putting this value in the 1, putting these values in 1, what you will get? These values in 1. Let this equation be now 1. Because you have already shown it. Sine inverse x plus, this is your result 1. So what you are getting? Here at place of x you are putting minus x, at place of y you are putting minus y. So minus will come common everywhere. Okay, let me write it. Sine inverse minus x plus sine inverse minus y is equal to what? Sine inverse x. X is what? Minus x. Here, please see. Minus x under root 1 minus y square plus y is what? Minus y under root 1 minus x whole square. Isn't it? So what it is? You are getting minus sine inverse x minus sine inverse y is equal to minus c, bracket you will take common. So it is what? Sine inverse x under root 1 minus y square plus y under root 1 minus x square. And this minus will cancel throughout and you get the result. Same result you are getting it. So it's not very difficult to prove it. Simple. Now let's try the other cases here for sine inverse x and sine inverse y. And what is that other case? Let us do it. Yes. Now we have to prove that sine inverse x plus sine inverse y is equal to sine inverse this thing if, yes, it is what we have to show that it is pi minus this thing. Okay, x is greater than 0, y if x is greater than 0, y and x square plus y square is greater than 1. So pi minus, what you have to show? That this sine inverse x plus sine inverse y is equal to sine inverse x plus sine inverse y is equal to pi minus. This result you have to prove under what condition? If x is greater than 0, y is greater than 0 and x square plus y square is greater than 1. Simple. Same thing. What you will assume? You will assume that sine inverse x is equal to theta 1 and sine inverse y is equal to theta 2, implying that x is equal to sine theta 1 and y is equal to sine theta 2. Now it's obvious x is greater than 0 means that sine theta 1 will lie between 0 to pi by 2 and likewise y will also is greater than 0, implies y is greater than 0 means sine theta 2 would be lying wherein in between 0 and pi by 2. So it will be anyway theta 1 plus theta 2 will be positive. Now so see one thing you can show, x is greater than 0, y is greater than 0. This implies what? That sine okay, let me write sine theta 1 is greater than 0 and sine theta 2 is greater than 0, implying further that theta 1 plus theta 2 is greater than 0 and this is less than what? Pi by 2 plus pi by 2. Okay. But now x square plus y square. Now this is important. X square plus y square is greater than 1. If this implies what? Please see. X is sine square, theta 1 exactly is greater than 1 minus sine square theta 2. And 1 minus sine square theta 2 is nothing but cos square theta 2. Isn't it? And cos square theta 2 you can well write to be what? Sine square pi by 2 minus theta 2 as in the earlier case. So what you are getting effectively is sine square theta 1 is greater than, see this, 1 minus this thing, this is equal to this is equal to, so you are getting sine square pi by 2 minus theta 2, implying that theta 1 is greater than pi by 2 minus theta 2 because sine theta is increasing function, This is what you need to write. And this will further imply that theta 1 plus theta 2 is greater than pi by 2. Now this is result which we are looking for. So here, whether we write this thing or not write, it will not matter much for us because yes. So now we will prove. Now see, further see what is theta 1 is less than 0 is less than pi by 2 and theta 2 likewise is less than 0 to pi by 2. So this implies what? Theta 1 plus theta 2 will be greater than 0, of course, and this will be less than pi by 2 plus pi by 2, that is pi. So effectively what you are getting here is that theta 1 plus theta 2 is greater than pi by 2 and from here, from 1, see you have already proved theta 1, this is 1 and this is 2. So we don't want this thing. From 1 and 2, what you are getting pi by 2 is this thing and this is less than pi. This is less than pi. So it is going beyond, see, because you want to take sine theta 1 plus theta 2, it is going beyond the interval. So what you need to do, you subtract theta 1 plus, so this is result 3, this from 1 and 2, see from 1 and 2, what you are getting this thing. So subtracting pi throughout, so what you will get, pi by 2 minus pi, so minus pi by 2 is less than theta 1 plus theta 2 minus pi, and this will be less than 0. Pi minus pi is what? 0. So this is equation 3. And now see, we are within the principal branch. This much of thing is within the principal branch. And this is the thing which we will now take into our cognizance. We will take sine theta 1 plus theta 2 minus pi, please see. So what it is? It is minus. This thing you can well write to be what? Sine of minus you take common, okay? And this becomes pi minus theta 1 plus theta 2. Okay, so this is what? Minus sine pi minus theta 1 plus theta 2. Okay, and this is what? This is pi minus. Sine pi minus means sine pi is there, so it is sine theta 1 plus theta 2. And you will be, the sign will also remain positive, so eventually you will get this much of thing. Okay, so this result now, and here you open it up. Sin theta 1 plus sin theta 2 is what? You can open it, it is sin theta 1 cos theta 2. You put the value, so eventually what you will get? X 1 minus y square plus y 1 minus x square. Okay, you expand it sin theta 1 cos theta 2 because this is sin theta 1 is what? X. Sin theta 2 is what? Y. So cos theta 2 will be what? 1 minus y square. 1 minus y square and similarly this thing. So this is how much? This is sin theta 1 plus theta 2 minus pi equal to this thing. So what you will get? This implies theta 1 plus theta 2 minus pi is equal to sine of inverse. Sine this much is this much. So theta 1 plus theta 2 minus pi will be what? Sine inverse of this thing. Sine inverse minus, and see this bracket, x under root 1 minus y square plus y under root 1 minus x square. This thing result now. Sine inverse minus this thing will become what? Minus sine inverse this thing. X under root 1 minus y square plus y under root 1 minus x square. Okay. Now, here see, you can I'm removing all this thing and I will be writing here now. Okay, because what I am observing is that students are unable to see beneath this thing. So from this result, what we are getting here, yes, theta 1 plus theta 2, put the respective values, sine inverse x plus sine inverse y is equal to, this pi I am taking other side, is equal to pi plus minus sine inverse, and this x under root 1 minus y square plus y under root 1 minus x square. So this is the result. This is the result which we wanted to prove. Under what condition? Under the condition that x is greater than 0, y is greater than 0, and x square plus y square is greater than 1. Y square is greater than 1. Now see what from this result we will prove the other result. That is, we will derive the result that sine inverse x plus sine in indirect way is equal to pi. At place of pi, now we could be writing, I think, minus pi. Yes, it is minus pi only. Minus pi minus sine inverse x under root 1 minus y square plus y under root 1 minus x square. Very simple. When what? When x is less than 0, y is less than 0, and x square plus y square is greater than 1. X square plus y square is greater than 1. So simple. This is a result which can be obtained from this result. This result. How? This result, what you need to do here simply at place of x, see here x is greater than 0. Now see what you will do. Minus x is greater than 0, minus y is greater than 0, minus x square plus minus y whole square is greater than 1, isn't it? And then see, put these values, putting these values in 1, putting this value, I call it a. This result, let me call a. Putting values in a, putting values in b, in a. Let me see what we get here. Is yes, if I put these values here, what I will get? Simply sine inverse minus x plus sine inverse minus y is equal to pi minus. Here see, pi minus sine inverse pi minus sine inverse what? At place of x, what I will write? Minus x under root 1 minus y is what? Minus y whole square plus then y is minus y and under root 1 minus x whole square. Close it. So this becomes what? This becomes sine inverse minus x. You use the property here. Minus sine inverse x minus sine inverse y, and this is what? Pi minus, and now minus you take common throughout the bracket, so you will find minus will make it plus sine inverse this whole thing, x under root 1 minus y square plus y 1 minus x square, and then you multiply with this thing, you get your result. Sine inverse x plus sine inverse y is equal to what? Minus pi minus sine inverse x under root 1 minus y square plus y under root 1 minus x square. And the result is established. So simple. Only see, what you need to do is, whether it is sine, tan, cos, you only need to make sure that these you don't jump your principal branch, and if at all you are jumping it, then of course see, you need to do some manipulation, and then we need to eventually the conditions which of course we are writing separately for all of them, be it tan, be it sine, whatever. Now see, we will quickly take up the last property here, and that will be for cos inverse x and cos inverse y. cos inverse x and cos inverse y. And these properties are simple. Cos inverse x plus cos inverse y is equal to, see, simple. Cos inverse, it is xy minus under root x square under root 1 minus y square. That's all. If what? If x plus y is greater than 0, of course, see, here x and y, what they are? If you can just tell x is greater than 0, and what is this? If x is greater than 0 and y is also greater than 0. Let me check in if it is both. If x plus y is greater than 0, only this much condition it is. X, it is not x. And of course, see, here cos inverse x, cos inverse y. So if mod x is less than or equal to 1, mod y is less than 1. Of course, see, then only see this cos inverse x and cos inverse y will be defined. So the only condition is like this. And the other condition would be if x plus y is less than 0, then this cos inverse x plus cos inverse y will be equal to 2 pi minus this thing. So that will be the other part which we will be proving, and that we will be seeing that there we are not only coming back into our principal branches because we will be jumping it, but we are making use of certain properties also. That is cos inverse minus x is equal to pi minus cos inverse x. So that we will quickly do it. First, see, very simple result, x plus y is greater than 0. So what you will do? You will assume that cos inverse x is equal to theta 1 and cos inverse x y is equal to theta 2, implying that x is equal to cos theta 1 and y is equal to cos theta 2. Okay, with this understanding, now see, x plus y, now x plus y is greater than 0, if this implies what? This implies that cos theta 1 is plus, okay, cos theta 2 is greater than 0, or cos theta 1 is greater than what? Minus cos theta 2. And minus cos theta 2, I can well write to be what? Cos pi minus theta 2. That's all. Now, cos is what? Cos is a decreasing function. If you look in the graph of the cos, it is just like this. In its principal branch, 0 to pi. In its principal branch, 0 to pi, it is like this thing. So, decreasing throughout. So, decreasing throughout. So, what it is? Cos theta 1 is greater than minus cos theta 2. So, theta 1, what we can write? Decreasing. So, it is greater than theta 1 will be less than pi minus theta 2. So, theta 1 plus theta 2 is less than pi. Simple. See, fine it is. Theta 1 plus theta 2 is less than pi. So, and whatever, see, x plus y is greater than 0. So, see, what the thing would be that this we can assume that suppose x is also greater than 0. Suppose x is also greater than 0. Here you assume that x is greater than 0, y is also greater than 0. Because here there could be a case. Okay, let it be like this. Theta 1 plus theta 2 is less than pi. Once it is less than pi, and theta 1 is, see where? It is greater than 0. Yes, theta 1 is greater than 0 for the obvious reason. The principal branch of cos inverse x is what? It is, cos, it is minus 1 to plus 1. Okay, cos theta minus pi by 2 to pi by 2, it goes to minus 1 to plus 1. Okay, so theta 1 is cos inverse x. Cos inverse x, so theta 1 plus theta 2 is less than pi. Okay. Cos, it is like this, cos theta. Cos theta, its principal branches from where to where? From 0 to pi by 2 to pi. And here it is 0, it is 1, 1 to 0, and then minus 1. It goes like this. Okay. So cos theta, and this is cos inverse theta. So in cos inverse theta, cos inverse x will go this way, and theta 1 will be like this. So yes, so theta 1 obviously will be greater than 0 and theta 2 will always be greater than 0. Now see here, this is result 1. Also you can write theta 1 greater than 0 because theta 1 is lying between where 0 to pi, and theta 2 is also greater than 0 because theta 2 is also lying between 0 and pi. So theta 1 plus theta 2 obviously will be greater than equal to 0. So that's another result. So this is result 2. 1 and 2 will give me what? 1 and 2 gives me that 0 is less than theta 1 plus theta 2 is less than pi. So once I get it, so I am in my principal branch. So what I can write? Cos theta 1 plus cos theta 2 is equal to what? Cos theta 1 cos theta 2 minus sin theta 1 and sin theta 2, implying is equal to what? Cos theta 1 is x, this is y minus under root 1 minus x square under root 1 minus y square. Take the inverse here, so what you will get? Theta 1 plus theta 2 is equal to cos inverse xy minus under root 1 minus x square 1 minus y square, and you get the result. Theta 1 plus theta 2 is nothing but cos inverse x plus cos inverse y. Here you should write here cos inverse x plus cos inverse y is equal to cos inverse and this whole thing, that is xy minus under root 1 minus x square 1 minus y square, and you prove the result. Now second part here is important. I will quickly prove it because then of course see there will be completion of this all the properties here. Let me see. So what is the property now? Here see the property will be, yes, now what we will be proving is cos inverse x plus cos inverse y is equal to 2 pi minus this thing, provided x plus y is this time less than 0. This is less than 0. Okay, that's all. We will proceed like this. So simple here. X, you have assumed cos inverse x theta 1, cos inverse y theta 2. So x is cos theta 1, y is equal to cos theta 2 as usual. So x plus y is less than 0. Now, here you write x plus y is less than 0. This implies what? Cos theta 1 plus cos theta 2 is less than 0, or cos theta 1 is less than cos minus cos theta 2. Minus cos theta 2 you will be writing at cos pi minus theta 2. And then say, since you have seen that cos theta is a decreasing function, so theta 1 is less than this thing, so what it means? Theta 1 is greater than pi minus theta 2. Pi minus theta 2. This value is less than, so this value ought to be greater than pi minus, implying that theta 1 plus theta 2 is greater than pi. And you know theta 1 where it lies between 0 and pi, theta 2 where it lies between 0 and pi. It is greater than pi, so effectively from these two, theta 1 plus theta 2 will be less than 2 pi. Isn't it? Less than equal to 2 pi. Of course, greater than 0, but it is already greater than pi. So this is say 1, this is say 2. This inequality is say 2. So from 1 and 2, what we will get? Theta 1 plus theta 2 is less than pi, greater than pi, and less than 2 pi. So what we need to do is, let us subtract pi throughout. So what we will get? 0, theta 1 plus theta 2 minus pi, and this is less than pi. So this thing is in the principal branch. Now, we will take this thing here. Once we have derived this result, then what we need to do is sine of this thing, theta 1 plus theta 2 minus pi, let us take it. Because now we are in it, this theta 1 plus theta 2 minus pi is in it. principal branch. So yes, so what it is, please see, theta 1 plus minus pi, taking minus, so sine minus, so it becomes pi minus theta 1 plus theta 2, pi minus this thing, minus sign here. So this becomes what? Minus sine, please see, minus sine theta 1 plus theta 2. Pi minus, it is in second quadrant, no change, so sine will remain sine. Pi second quadrant, sine of sine function is positive, so you eventually get this thing. Put these values here, minus. When you put the values here, what it is sine theta, you will expand, what you will get? Sine theta 1 cos theta 2 plus cos theta 2 sine theta 1, putting their respective values, what you will get? X, no, sorry, very sorry, you are not taking sine, you are taking cos here. Please type cos. You are not, sorry, very sorry. It is for cos, you are proving this result for cos theta. So cos is cos, please see, sorry, some mistake here, please make this correction, it is cos. Now cos minus sine. So cos minus theta is cos theta, so no need of this thing. It will be cos pi minus theta 1 plus theta 2. Okay, minus cos minus theta is cos theta. You can write here. If you need be, you can always put the reasoning there in front of it. Because cos minus theta is equal to cos theta. Reason it out in front of it. And then cos pi minus this thing is what? Minus cos theta 1 plus theta 2. Okay, and then this thing, what it is? Cos theta 1, cos theta 2, cos minus sine theta 1, theta 2. Putting their respective values, what we will get is x into y minus under root 1 minus x square, 1 minus y square. Good. So this is what? This is cos theta 1 plus theta 2 minus pi is equal to 2. Okay, so theta 1 plus theta 2 minus pi. Theta 1 plus theta 2 minus pi will be equal to what? Cos inverse of minus this whole thing. Xy minus under root 1 minus x square, 1 minus x square under root 1 minus y square. Okay, cos inverse of minus this thing. Now you know there is a property that cos inverse minus theta is what? Pi minus theta. So what you would be writing it is pi minus cos inverse and this will be xy minus under root 1 minus x square under root 1 minus y square. So, and put the value of theta 1 plus theta 2. Theta 1 and theta 2 is what? Cos inverse x plus cos inverse y minus pi. Okay, so now you have got the result. You take it on the other side and you get your result. That cos inverse x is plus cos inverse y is equal to minus pi taken this side is equal to 2 pi minus cos inverse x y minus under root 1 minus x square under root 1 minus y square. This is the result which you were looking for. So we have completed almost all the properties here. Now I tell you one more thing before I take up your exercise. Now your exercise, the question given in your exercise, you will find them to be almost very easy. But I would request you that you move beyond this NCERT and try some good questions also. Because now the entire theory has been given to you. Now one more thing I would like to here enlighten you. That yes, that at time C, you have proved sine inverse x plus sine inverse y is equal to like this thing. I am just showing it to you. Sine inverse x plus sine inverse y is equal to, you have written like that, this is sine inverse x under root 1 minus y square plus y under root 1 minus x square. If number 1 x y is less than 0, or if xy is greater than if xy is greater than 0 and x square plus y square is less than 1. Now, and this is equal to what? This is equal to pi minus sine inverse x under root 1 minus y square plus y under root 1 minus x square if what? If, yes, see, y is greater than 0 and x square plus y square is greater than 1. X square plus y square, just check it from your this thing, it is okay. X is greater than 0, y is greater than 0. No, it is x greater than, it is not xy greater than 0, it is x greater than 0 and y greater than 0. If x is greater than 0, y is greater than 0 and it is minus pi minus same thing if x is less than 0, y is less than 0 and x square plus y square is greater than 1. Now see here, these results we have already derived. Now suppose you have to derive sine inverse x minus sine inverse y. This result you have to derive. So what you can do here? Again see, you can derive it from here. How? See here, simple thing is, this thing you can well write to be what? Sine inverse x plus sine inverse minus y. And then see, try to put it in these values. So see what the thing will turn out to be. So here see, sine inverse x minus sine inverse y, suppose you want to put it out. So what you are getting here is that xy is less than 0, or if x is here, x is greater than, it should be x should be greater than 0. Where it is, xy is greater than 0, xy is greater than 0 and x is greater than 0. Okay, yes, both the cases, xy is greater than 0. So what you need to do is, rather I will be giving this as an exercise to you people. Try to update this result. How you will be updating sine inverse x minus sine inverse y formula you have. You can write this way. And wherever this y is coming, here, we make it minus y. So what will happen? If you make it minus y, what it will give you? X and minus y, if you put at place of y, you put minus y. So what it means? Xy is less than 0, so xy will be greater than 0. And so that is the condition. Then xy is greater than, wherever y is coming, that you put it minus y here. Whatever the formula comes up, that will be for sine inverse x minus sine inverse y. Here x is greater than 0, y is greater than 0. So here, what is this formula? In this formula, what you will do? Here, x of course is greater than 0, you keep it. Y greater than 0, at place of y, what do you want to? Minus y. So minus y is less than 0. So condition would be, if you want to make use of this thing, see, I tell you, what will be its counterpart? If x is greater than 0, minus y is less than 0 and x square plus minus y square is greater than 1. Is greater than 1. Because here see, it is not affecting anything. Minus y square, so you are getting x square plus y square. So that is the only difference. But here see what you will get is, here this thing will become what? Sine inverse x, y you are putting minus y, so it will sine inverse, so what you will get? Sine inverse x minus sine inverse y, isn't it? And pi minus, okay, you better write sine inverse minus y, is equal to what? Pi minus what? Sine inverse, wherever this y is coming, you put it here. Y minus y will not make difference, so you can keep it as such. Plus here it will make a difference. Here y is to be replaced with minus y. So 1 minus x square. So this is the thing which you have to take into consideration. And then see, this will become what? Sine inverse x minus sine inverse y. At pi minus, this thing will become what? Sine inverse, you write the whole thing like x under root 1 minus y square and minus y 1 minus x square. And what will be the condition? If x is positive, y is minus y is less than 0, so y will be what? Multiplied with minus y. So this thing. So what you are getting is, no, minus y will be greater than 0. Please see, here minus y, please see if it is y, yes, minus y is greater than 0. So y will be less than 0 and x square plus y square will be less than greater than 1. This is how, this is what you would be doing for obtaining this type of problem. Okay, problem I will take on my next lecture because we are already at some 25 minutes here. So thank you, students. We will meet next day, means today is Monday. Wednesday again we will be meeting, same time, same mode. Thank you.